Assalamualaikum and hi everyone. We are students from JCDCS 1432B. In this video, we will be discussing on application of differentiation.
What is differentiation? Differentiation is a fundamental process in calculus where we find the derivative of a function representing its rate of change. There are 5 applications of differentiation that we have learned, which are related rates, analysis of functions, maximum and minimum values, Rolle's theorem, and also mean value theorem. In this video, we'll be focusing on related rates. Related rates problem often involve finding the rate at which one variable changes by relating it to others whose rates are known. The importance of related rates cannot be overstated. When one's variables is known, we can precisely determine how that rate influences another. These problems find extensive application across various fields, such as finance, physics, travel, and also transportation. Whether calculating how fast a car's distance changes with time or determining financial growth rates, related rates are indispensable. Last but not least, framing problems in terms of related rates allows us to write a rate of change in terms of another rate of change. So, how do we tackle a related rates problem? Let's break it down step by step. First, identify which variables are changing and need to be related. Secondly, find an equation that connects these variables and their rates. Thirdly, take the derivative of both sides of the equation with respect to time, which is d over dt. Next, substitute all known values and rates given in the problem. Finally, solve for the rate of change of the unknown variable. By following these steps, we can transform a complex problem into a manageable equation, allowing us to compute rates of change precisely. Whether predicting future trends or understanding physical phenomena, related rates provide a powerful tool in our mathematical toolkit.
Hello everyone! So today, I'm gonna talk to you about our acknowledgement to our lecturer, friends and family. First of all, we would like to express our gratitude to our calculus lecturer, Dr. Shamsatun Naha, for her guidance in our group project. Thanks to our madam, we can complete this group project perfectly. We would also like to thank our parents for their unconditional support and believing us to complete this task. Not to forget our friends who extended their moral support to us and support us along the way. Thank you.
Our problem statement is a boat is pulled into a dock by rope attached to it and passing through a pulley on the dock position 9 meters higher than the boat. If the rope is being pulled in at a rate of 2 meters per second, how fast is the boat approaching the dock when it is 12 meters away from the dock? So let's solve this problem together. To solve the problem of how fast the boat is approaching the dock, we will use related rates in calculus. Here are the step-by-step to solve this question. First, we need to identify the known variables including rates of change and the rate of change to be found. So the situation from a right triangle where x is the horizontal distance from the boat to the dock, 9 meters is the vertical distance from the boat to the pulley, z is the length of the rope. Given information, the rope is being pulled in at a rate of 2 meters per second, where dz over dt is equal to negative 2 meters per second. We need to find dx over dt when x is equal to 12 meters. Next, we need to construct an equation relating the quantities whose rates of change are known to the quantity whose rate of change is to be found. Related distance using Pythagoras theorem, x squared plus y squared equal to z squared. We need to find z value when x is equal to 12 and y is equal to 9. Then we will get z is equal to 50. Differentiate both sides of the equation with respect to time. The chain rule is employed at this step with the respect of time t. Here, we use the chain rule formula, which is the uv prime plus vu prime. Then we have to substitute the known values into the equation. After that, we will get the value of dx over dt, which is -5/2 meter per second. So here, the boat is approaching the dock at a rate of 5/2 meters per second when it is 12 meters away from the dock. The negative sign indicates that the distance x is decreasing.
So here I am again to talk to you guys about what we can conclude from this topic. So for the first conclusion is we can learn a general strategy on how to solve this problem solution, as this is one of the hard questions in our final exam. We have listed out the steps on how to answer related rates problem as to make students to easily understand and answer this topic in the final exam. Other than that, we also can identify the keywords in the problem statement as we understand what the question needs. Lastly, we now know that we have to use suitable method to differentiate the relationship as to get the correct answer. As a reminder to you guys, we must not be careless in our calculation as this makes us to easier lose marks. Thank you.